This is Geometry, Unit 9, working on Day 8's homework, the perimeter and area worksheet. We're looking at formulas. Formulas you should definitely know. To find the area for a rectangle, we can call it length times width. We can call it base times height. For a triangle, often known as half of base times height. And our distance formula, the square root of x2 minus x1 squared plus y2 minus y1 squared. So we'll use that these formulas throughout this worksheet. So here we're going to look for the area. Well, we've talked about in previous lessons and notes that area is the number of squares that can be formed over this total area. So we would assume that 8 of the squares were across this side and 18 of the squares were running up that side. So we need to say 8 times 18, which gives us 144. So 8 times 18, the area would be 144 units squared, because those are the number of square items that would be in that region. The perimeter. The perimeter can be known as twice the length plus twice the width. That's always an easy way to add up the perimeter on a rectangle. We know that the length, let's call it 18. Call the width 8. You could say 8 plus 18, 8 plus 18, or you could use a formula like so. 36 plus 16. So the perimeter comes out to be 52 units. They're not squared because it's a length. It's like a fence around a property. Looking for the area of our triangle. Well, here we have two sides that are the same, so we know this is 15. If those are the same, a point that is equal distance to the end point lies on the perpendicular bisector. So we know this is perpendicular, and we know it cuts it exactly in half. So we know 9 millimeters is on that side. So to find the area of a triangle is half the base times the height. The base is 18 and our height is 12. We can take half of the 18 or we can take half of the 12. You just can't take half of both. You can multiply that together and call it 216 and take half of that if you wish. Either of those ways you'll get the same answer of 108. These are millimeters squared. So if each square that was sitting inside here was 1 millimeter by 1 millimeter, there'd be 108 of those total. The perimeter. The perimeter is the sides of the triangle. So in this case, we know we have a length of 15, another length of 15, plus that length of 18. So that comes out to be 48 millimeters. Here we're looking at a rectangle and a triangle combined. We're looking for the area. The area, we're going to break this up into two pieces. We have a rectangular part and we have a triangular part. The area equals the rectangle plus the triangle. Well, the rectangle is 25 times 19. That's the base and height, or length and width if you want to call it that. That's the area of this rectangle. Now we got to think about the area of this top part, almost the roof of a house almost, it looks like. A lot of people like to think, well, in our notes, we had to find this length, which would be fine. It would make it a little tricky for the values that they've given us. We know that this side here is going to be 25 because it's the other side of the rectangle. But remember what base and height have to be. They have to be perpendicular. Well, this square indicates that these two sides are perpendicular. So you could use one of these for the base and one of these for the height. So we're going to say half of 15 times 20. So that's going to come out to be 475 plus 150. So we have 625. These are inches squared, or square inches. The perimeter, you got to be careful on the perimeter, because notice the perimeter would be 19 on this side. We don't need to worry about the 25 in the middle of the shape. We're just going on the outside. That's the perimeter, on the outside of the shape. Not the edge of the rectangle and edge of the triangle, but the very outside of the whole shape. So we have a 19, a 15, 20, 19, and 25. So our perimeter here is going to add up to be 98. These are inches. We're going to plot our point, 2 over 4 up. Six over 2 up, and 2 over 1 up. So we have a triangle, and we're going to be looking for the perimeter and the area. We're going to look for the distances of each of these sides. AB. Notice that AB is slanted. So if AB is slanted, we're going to need to calculate using the distance formula. So x2 minus x1 and y2 minus y1 gives us 4 squared plus negative 2 squared. 16 plus 4 is the square root of 20. You can break the square root of 20 down if you want. You can call it 2 times 10. You can call it 4 times 5. Those are both ways to multiply to be 20. Notice what's special about using 4 times 5 is you know the square root of 4. Square root of 4 is 2. 2 root 5, because you don't know the square root of 5. So that would be simplifying. But typically, we'll only need the square root of 20. BC. BC would be 6 minus 2 and 2 minus 1. That gives us 4 squared plus 1 squared. 16 plus 1 is the square root of 17. Now 17 is a prime number. It can only multiply to be 17 is by 1 and 17. So there's no way to break that one down. And then AC, AC is vertical, so we can just count that. We get 3. So to calculate the perimeter is going to be 3 plus the square root of 20 plus the square root of 17. We can't bring those together any better than that than with decimals. So let's look at the decimal version of this. That was using our calculator. So the perimeter is going to be 11.59 units. Otherwise, this would be the best that you could do. The area. The area, we have to know base times height. Well, when we look at this shape, we're looking for any right angles. All the vertices, neither of those are right angles. So are there any sides that you could easily calculate? You could figure out perpendicular that way. It's possible. Perpendicular this way. But it looks to be the easiest if we went perpendicular this way. 1, 2, 3, 4. And perpendicular to that horizontal would be vertical. 1, 2, 3. So I know that the area is going to equal half of 4 times 3. Half of 12 is 6 units squared. On the back side, we're going to look to plot these points. As we look at the points real quick, we notice that one of the dimensions is 10. 1, 2, 3, 4, 5, 6, 7, 8. Doesn't look like the 10 is going to fit. So you could either make it float out there by itself, which isn't typically as accurate, or we could change up the scale. If you change up the scale, it's pretty important for you to show what you're changing up. So a lot of times, if you're going to change up the scale, it's a good idea to change them both so they stay the same. So we'll change that to become 2, 4, 6, and 8. And this side here would be 2, 4, 6, and 8. So we'll go by 2's. So to plot the point 3, 3, that would be 1, 2, 3 over, and 3 up. That would be A. B, 2, 4, 6, 8, 10. 3 up. 2, 4, 6, 8. 1, 2, 3. And then 1 over and 3 down. It's point D. So when we break it in small like that, we're going to find the length of each of these sides so we can find the perimeter. Well, AB, you can practically count 2, 4, 6, 7. DC would also be 2, 4, 6, 7. But now, counting that slanted amount, we're going to need to use the distance formula. So we'll calculate BC. 10 minus 8 squared plus 3 minus a negative 3 squared. 2 squared plus 6 squared minus a negative makes a positive. 3 plus 3 makes 6. 4 plus 36 leaves you with the square root of 40. Well, you could break down the square root of 40. 2 times 20, 4 times 10. What's good about 4 times 10 is you know the square root of 4. It's exactly 2. 10 can be broken down into 2 times 5, but there's no perfect squares of that. Nothing else can be broken down. So 2 square root 10 would be our best option. And a very similar answer over here with AD. So we'll get 3 minus 1 and 3 minus a negative 3. 2 squared plus 6 squared, 4 plus 36, square root of 40, 2 root 10. So we have 2 sets of sides. Opposite sides are congruent. We know that this is a parallelogram. We're going to calculate the perimeter. Well, the perimeter would be the 7 plus the square root of 40 plus the 7 plus the square root of 40. So you could call that 2 times 7 plus 2 times square root of 40. That would be a formula. Twice the length plus twice the width could be another way to write it. So we're going to get 2 times 7 plus the square root of 40, kind of factor out that 2. Anyway, the perimeter is going to equal 26.6 units. And because it's a length, we do not square the units. They're not counting squares, they're counting length. Area of our shape. To calculate area, we need to look at the parallelogram, and we'll need to know base times height. I don't have any perpendicular sides here, so I'm going to have to look at coming straight up. So that makes this triangle. And I'll have to look at going straight down. That makes this triangle. Then I have a rectangle in the middle. The rectangle in the middle, remember the units go by 2's. So 1 to get to there, 2, 3, 4, 5, 6, 7. 2, 4, 6 and a half, which would make it 7. Same thing here, 2, 4, 6, 7. Well, I'm sorry, we only need to count to the edge of the square. 1, 2, 3, 4, 5. So 5 to there and 5 to there. Same thing down here. 5 is just to this spot. Here, halfway is 1, 2, 3, 4, 5, 6. If that's 6, and that's 5, this needs to be the unit of 2. And so would this. This would be a unit of 2. So we have to figure out what this length in here is going to be. Well, if we're looking for the area, we're going to do base times height. So we have 7 for a base and 6 for a height. So now we're going to look at the area. The area is base times height. 7 times 6. 7 times 6 gives us an area of 42 units squared. So what we needed to do, again, we needed to break this parallelogram up into 3 sections. We got 2 triangles and we have this rectangle in the middle. a parallelogram has the formula of base times height, just like a square does. Or you could break this up into actual triangle, rectangle, and triangle. That would be another typical way. 2, so we're going to say half of 2 times 6. That's the triangle. Comes out to be 12 divided by 2 is 6. There are 2 of them, so that's 12 for all the triangles, plus the 5 times 6, which is 30. And that adds up to be 42. These two numbers add together, 2 triangles of 6 apiece, plus the 30 gives you 42. That helps verify that this was base times height. Find the perimeter of the figure with these vertices. 4, 0. 3, 3. Negative 1, 3. Negative 4, 0. Negative 1, 3. And 3, negative 3. So we'll connect those all together. And to find our lengths, AB is slanted. So we're going to need to say 4 minus 3 squared plus 0 minus 3 squared. One squared plus negative 3 squared comes out to be 1 plus 9 is square root of 10. Square root of 10 can't be broken down. BC is horizontal. You can count that to get 4. CD is slanted. So we get negative 4 minus negative 1. And 0 minus 3. That gives us negative 3 squared plus negative 3 squared, which is 9 plus 9. You can't take the square root of those. This is the square root of 18. You could break that down if you wish. 18 is 9 times 2. You know the square root of 9, but there'd still be a 2 left inside. DE, negative 4 minus negative 1, and 0 minus negative 3. So again, that comes out to be 9 plus 9, which is the square root of 18. FE is horizontal, so that's 4. Then we have 4 minus 3 squared plus 0 minus a negative 3 squared. We're getting our numbers from the coordinates. x2 minus x1, y2 minus y1. Nine plus 1 is 10. So to calculate out our perimeter, The perimeter is going to be 2 square root 10s. We have 2 of those. We have 2 lengths of 4. And we have 2 lengths of square root of 18. So using our calculator, that'll come out to be 22.8 units. Now, thinking about the area. This could be a little tricky to think about area. How could we break this down into rectangles and triangles? If we come straight down here, we could have a triangle. And if we come straight down here, we could have a triangle. That would be your most common, probably, way to break this down. Now we have to find the area of each of these triangles. Well, we have to look at what sides can be perpendicular to each other. These, because it's a slope of -1 and a slope of +1, those are actually negative reciprocals of each other. You could use length DC and length DE, multiply those two together, and divide that by 2. That would work out just fine. But most likely, you would use this length here, 1, 2, 3. It's a length of 3. Here it's a length of 3, 4, 5, 6. Across the top we have the length of 4. This side is also 6. But this height is only 1. This clearly is not perpendicular. So to calculate our area, area is going to equal triangle plus rectangle plus triangle. The triangle is half of 3 times 6. The rectangle is 6 times 4, and the other triangle is half of 6 times 1. That gives us 18 divided by 2, which is 9, plus 24, plus 3. That comes out to an area of 36 units squared.